Hello everyone. Today let's solve the problem party. Right. So this was asked in the Codeforces beta round 87 division 2. Right. So here you can just go through the question. This is easy to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Right. So what the question states here. Just give me a second here. One second. One second. So yeah. Here we are given a tree-like structure, right? So we are given a tree-like structure of employees and their managers. So we have been given tree-like structures of employees and managers. Employees and managers, right? So here an employee can only attend the party if he is in the same group. An employee can only attend the party if he is in the same group. If no one in that group is their superior, right? An employee can only attend the party in the same group if no one in that group is their superior, right? So just keep this in mind. To ensure this, we need to find the maximum depth of the employee. So to ensure that, we need to find the maximum depth. Means you would have already guessed that we can go with the depth first search, right? So to ensure that, we need to find the maximum depth of any employee in the management hierarchy, as every level of the tree must be separated into different groups, right? So again, I'm gonna read these two sentences. We are given a tree like structures of employees and managers, right? So an employee can only attend the party in the same group if no one in that group is their superior. And to ensure this, we need to find the maximum depth of any employee in the management hierarchy, as every level of the tree must be separated into different groups. So what is the answer, or what is the solution here? The answer is the maximum height among all the management trees, right? So the answer is the maximum height among all the management trees that is formed from the root to leaves. So this part is very important, man. Just listen to this again. The answer is the maximum height among all the management trees formed from the root to leaves. So this is important, right? So this can be done using the simple DFS traversal on the employee hierarchy graph. So we will be making use of the DFS. So we will be making use of the DFS along with the backtracking, or the recursion, right? To recurse, we'll be making use of the backtracking basically. Main thing is we'll be going with the DFS and backtracking. Just keep this in mind, right? So let's come to the question part here. So just give me a second here. One second. Yeah. So see here, we have been given the hierarchy, right? So we have been given the hierarchy. The output that we need to get here is, or the maximum depth that we need to get here is 3. The maximum depth of uh, any employee in the management hierarchy should be 3 for this particular input, right? Should be 3 for this particular input. So let's see, let's consider the same example within the approach. We have been given only one example for this one, right? 5 total, this one inputs 1 2 3 4 5. So forget about the 5. This is the input, right? Minus 1 1 2 1 and minus 1. This is the input basically. We are having 5 inputs. Minus 1 1 2 1 minus 1. This is the hierarchy, and the output that we need to get here is 3. The output that we need to get here is 3, right? So just keep this in mind. So they have given us wonderful example just for the sake of understanding. So the output that we need to get here is 3, right? So I hope the question part and the this one input output part is completely clear. Now let's hop into the this one approach part. So let's go with the approach followed by the, what do you call, let's go with the approach followed by the complexities, and then let's write the code, right? So first, as usual, let's go with the approach. So I have considered the same first input here, first example that they have given in the question, right? So here we have 5 inputs, minus 1, 1, 2, 1, and minus 1. The output that we need to get here is 3, right? So we will be going with the recursive, this one, DFS, or the DFS with the backtrack. DFS with the backtrack mainly, right? So we will be going with the DFS with the backtrack. Just keep this in mind, right? So let's move on with a step-by-step explanation here. So employee 1 and employee 5 have no manager. Means employee 1 and 5 doesn't have the root here. Employee 1 and 5 doesn't have the root here, right? So here what happens? Employee 1 and 5 doesn't have the manager, means this is considered as root. This is considered as roots. Employee 1 and 5 is considered as roots, right? So just keep this in mind. Employee 2 is managed by 1. Employee 2 is managed by 1. See here. Employee 2 is managed by 1, right? So we can write in this way. 1, employee 2 is being managed by 1, right? So we can write in this way. And also this one, what do we call, just give me a second here. Employee 3 is being managed by 2. Employee 3 is managed by 2, right? Employee 3 is being managed by 2. So here in this case we can write in this way. We can write in this way. 1 2 3, 1 2 3, right? So here, because 2 is already being managed by 1 and 3 is managed, 3 is being managed by 2, so we can write in this way, right? So we can write in this way, 1 2 3. And the next step is employee 4 is managed by 4. Employee 4 is not managed by 3. Basically employee 4 is managed by 1 directly, right? So we can write in this way. We can write in this way, right? We can write in this way. So we have two trees now. We have two trees. One is we have 1 to 2 to 3. This one is being 2 is being monitored by 1 and 3 is being monitored by 2. So we can write in this way, which is having the depth 3, which is having the depth 3. And tree 2 we have root 5 directly. Root 5 directly. This is considered as root, right? This is considered as root because they are not managed by anyone. 1 and 5 here, I have said this one earlier. Employee 1 and employee 5 have no manager here, right? So this will be considered as roots. This will be considered as roots 1 and 5. But for 1, 1 is monitoring 2 and 2 is monitoring 3. So this we can represent this in this way, 1 2 3. But 5 we have root and depth is also 1. Depth is also only 1, right? So just give me a second here. What happened? 1 second. Yeah. So this one, let me come here. The depth is only 1. So the depth of this one is 3 and the depth of 5, this part is only 1. This part is only 1. We will consider max of 3 comma 1. Max of 3 comma 1, nothing but here in this case we will get 3. We'll get 3. So maximum depth that we got here is 3 accordingly with the DFS, right? The maximum depth that we got here is 3, where we now know that this one, three groups are required. We now know that three groups are required. So final output that we got here is 3, right? So the final output that we got here is 3. This one I'm speaking of. Now we have three groups required. So the final output that we got here is 3. This one. The output that we got here is 3, which is equivalent to the output that they have given for the example 1 in the question. So our approach works absolutely correct in this case. Now, as we are completely familiar with the approach, let's move on with the complexities part, right? So the time complexity here would be big of n, right? Why? Because here we are visiting the each node exactly once in the DFS traversal. We are going with the DFS along with the backtracking. Uh, if you would have heard this one, if, we just now went with the approach, right? So we discussed the same basically. We will be going with the DFS with backtracking, or accordingly with the approach we went with the DFS along with the backtracking. So we are visiting the each node exactly once in the DFS traversal, which will lead to the time complexity of big of n. So what would be the space complexity? Space complexity would be big of n as well, because we will be storing the adjacency list, and uh, a recursion stack in the worst case can go this one, go up to big of n depth, right? So we know that one. Recursion stack in the worst case can go up to big O of n depth. It's better to write big O of h when we are making use of the recursion, but we are storing the adjacency list as well, which is of big O of n, and the recursion stack in the worst case would lead to big O of n as well. So we can just go with the big O of n for the space complexity. The time complexity and the space complexity for the code that we'll be writing in the future would be big O of n, big O of n, right? So I hope this part is completely clear. I hope this part is completely clear. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. And now let's start writing the code. I'll just come to the compiler. So what we'll be doing here, we'll be making use of the input output means fast input and output, buffer data and print writer, along with the different utilities. So let's import the input output and utility package first, right? So I'll just go with import java put output dot star. This is fine. import java dot util dot star. So this is fine. The next step is let's go with the class main. So this will be class main. This is fine. So within the main class, what shall we do? Let's go with the adjacency list for the tree representation. So this will be static. This will be list. So I'll just go with integer here. So this one will be graph. This is fine. So the next step here would be we have to store the maximum depth of any tree, nothing but this is our answer basically, right? So we have to go with the maximum depth in that case. So we have to store the maximum depth of any tree. Basically this is our answer, so we can just go with the variable max depth here, right? So which is of the type int. So I'll just go with the max depth and initialize this one to 0, right? So the next step would be let's go with the main method. So I'll just go with here. Let's make use of the this one throws input output exception as well, or else we'll get the error. So this one is fine. Next let me remove this one entirely. This is fine. So within the main method, what shall we do? Let's go with the fast input and the fast output. This is nothing but buffered mm, reader. This one br equals new buffered reader, new input stream reader system dot in system dot in. So this one will be print writer output equals this one will be new print writer. This one will be system dot out. This is fine. So the next step would be we have to go with the number of employees as well as we have to initialize the graph with n plus 1, nothing but one index, right? So first let's go with the number of employees, nothing but here. Let me consider variable n, and this is of the type integer. So I'll just go with integer dot percent of. So we have to read this. I'll just go with buffered reader dot read line. So we have made use of the read line a number of times now. We should be knowing the input output, but same thing I'm going with for each of the problem, or for every problem, most of the problems, right? So now let's initialize the graph with n plus 1 because we have to go with one index, not the 0 index, right? So here let me initialize the graph to new list of within the array. I'll just give n plus 1. This is fine. This is easy, right? So let's initialize the each list in the graph. Let's initialize the each list in the graph. For that one, let's go with the let's move on with the iteration part. So this one will be int I equals 1, I less than or equal to n. This is fine. I plus plus. This is fine, right? So here, what we are doing, we are initializing the each list in the graph, right? So this is fine. I less than or equal to n I plus plus. So let me do one thing here. Hmm. So let me write this one here itself. Iterated value of the graph. Let's assign this one to new array list. Yeah, this is fine. The next step is we have to go with the list of the root employees. Means the employees who are having no managers, roots. In our case, we had 1 and 5, which didn't had roots or managers, right? Those are considered as roots basically, right? So the employees without managers are considered as roots. In the first example that we considered in the approach, 1 and 5 were the roots which didn't had managers, right? So that one, let's do the same. Let's consider the same here, right? So here I'll just go with the list which is of the integer. This is fine, data type is integer. So I'll just go with the roots equals new new array list. This is fine. So let me come out of this one. Sorry, yeah, let's move on with the further steps. We have to read the manager info for each employee as well. Each employee, again, you would have guessed. Let's move on with the iteration now. Int I equals 1, I less than or equal to n. So next part is let's increment the I. This is fine. Within the for loop, let's go with the iterated value of the p, and let's assign this one to integer dot percent of this one will be buffered reader dot read line, buffered reader dot read line. So this is fine. Let's go with the if condition. Iterated value of the p, if it is equal to -1, then what shall I do? Then what shall we do? So here, let me go with roots dot add of this one I. In simple terms, if employee has no manager, we are considering that one as root, right? So that's what we have done by making use of the if condition, right? Simple if condition here. Else, if the manager has, if the employees is having the manager, then we have to build the tree, right? And then we have to go with the manager to employee. So in our case, it was 1 to 2, 2 to 3, because 1 was monitoring 2, and 2 was monitoring 3, right? 1 was monitoring 2 and 2 was monitoring 3. So for that, we have to build the tree, nothing but manager to employee, right? So I can just write here, else, uh, graph graph of this one p of I, this one graph of p of I, this is fine. Let's go with I add of I. So this is fine. Let me come out of this one entirely, man. Let me come out of this one entirely. We have to perform the DFS from every route to find the maximum tree depth. So as we are going with the recursive DFS or the backtracking part, we have to perform the DFS from every route to find the maximum tree depth. In our case, I can just go with a simple for loop here. This one will be int root of roots. So this is fine. Int root of root. So here in this case, we'll be making use of the backtrack. So before making use of the backtrack here, let's go with the helper function backtrack. We have to perform the backtracking, right? So here, this is nothing but the DFS to compute the maximum depth of the tree. We will be going with the backtrack or the recursion. Means in simple terms, it is recursive DFS here. So we will be performing the DFS along with the backtracking to compute the maximum depth of the tree here. So we will be making use of the backtrack helper method or the function. So here I'll just go with static void. So this one will be backtrack of two parameters. One is I need node and another one I need depth. Another one I need depth here. So within the backtrack method, so we have to update the maximum depth. So this one will be max depth equals max dot math, right? So this one will be making use of math here. Math dot max of same thing. Let me copy paste here. Just give me a second. This one will be max depth. What happened to this one? Did I press insert? Yeah. Max depth, comma depth. This is fine. So let me close this one entirely, man. So this is fine. We just have to update max depth, right? So if we find the max, so this is fine. Again, let's go with the for loop because we have to visit all the subordinates, right? And we have to recurse with the increased depth as well. We have to visit, in simple terms, we have to visit all the subordinates and we have to recurse with the increased depth. Let's articulate the same thing in the form of code now. So this will be for in child of this one. What do we call? Graph of node. This is fine. Uh, Within the for loop, let's go with a backtrack or let's recurse with increased depth. Nothing but here backtrack of child, comma depth plus 1, child comma depth plus 1. So this is fine. We are done with the backtracking part. So now we can make use of this one helper function or the helper method within this for loop, right? So where we were performing the DFS from every route to find the maximum tree depth. So here we left here the line number 27 I'm speaking of, right? We are performing or we have to perform DFS from every route to find the max tree depth. We have already written the helper method for that one, right? So let's make use of the backtrack helper method within the for loop. So I'll just go with the backtrack of route. We have to start from the root, right? So root comma 1. So this is fine. The next step is the final one. We are done with the logical part. Next step is we have to print the final result and we have to flush the output buffer. We have to print the final result and we have to flush the output buffer, right? So for printing the final result, I'll just go with the out dot println this one of maximum depth, and also the next part is we have to flush the output, nothing but out dot out dot flush. This is fine. We are done with the coding part. Means the last two steps were we were printing the, I mean we are printing the this one final result, and here finally we have to flush the output buffer. You can just make use of the out dot flush or out dot close. So here I forgot to give parenthesis here. This is fine. Out dot flush or out dot close, both works, right? So this is fine. This is it for the code. Before checking whether with the different inputs whether the code works correctly or not, let's do one thing. I'll just copy paste the signature starter template. Just give me a second here. So here let me paste this one. So here this is fine, right? This is fine. You just let's just concentrate on the logical part rather than this one. This is fine. So I'll just come here. Let me copy this input. The output that we need to get here is 3. We have only one example, right? So let me paste it over here. Let me hit the run button. So we are having, huh, where? Line number 53. I have missed something, man. Backtrack of root comma 1. Why I have written here? This has to be node and depth, right? So we have considered the parameters node and depth. I don't know why I have written. So this is fine. Let me run this one again. Max depth spelling D instead of closing. So here line number 56, where is it? So this one has to be closing parenthesis, and let me delete the D. Let me run this one again. So here line number 56 again. Why this happened like this? So we have, why I have given max depth equals max depth of comma depth, it has to be, right? So this one, let me do one thing. Let me remove this one entirely. This one has to be depth. This is fine. This one has to be depth. This is fine. Let me run this one. So now this is fine, right? For in child of graph of node. So we are just visiting all the subordinates here. This is fine. And child comma depth plus 1. This is also fine. We are recursing with the increased depth here. This is fine. Accordingly with the approach that we discussed. Same thing. We are just calculating the maximum depth using the backtrack helper method. So this is fine. So now what error we have? How many errors? 3 errors again. Working. This is warning. Let's leave the warning part. Let's come to the line number 38 here. Cannot find the symbol p of I equals -1. Variable p. So where is it? Line number 38. Mm, hmm. So here, where I have written int, so just give me a second. For loop, this is fine. Before this one, list of integers, this is fine. Mm, so here we have to go with the, we have to assign the p of I, means iterated value of the p to manager of the employee I, right? So where did I do this one? Why this for loop here? So this for loop, we are initializing each list in the graph. So that is the reason we are going with the array list. This is fine. Oh yeah, this one is fine. I have forgot to assign this one iterated value of the p to manager of the employee. This part I have missed completely. So let me do one thing. That is the reason it is not considering the this one. It's giving the error basically. So this one has to be new int of n plus 1. So we are just assigning the iterated value of the p to the manager of particular employee, right? Particular employee I here. So this is fine. Let me run this one. Hope this error will be gone, man. So yeah, now we have the output 3. So we are getting the warning. This is fine. Just ignore this part. Just getting the warning. We are getting the correct output, right? 3. So now this code works absolutely correct. This line I entirely forgot. So we didn't initialize the p to p at all, right? So that is the reason it was giving us error. Basically here we have made use of the p but didn't initialize p anywhere, right? So that was the reason we were getting the error. Also one more thing here, some something happened. I think I don't know why that depth and all came here. So maybe typo, you can consider that one as typo. Leave it. So here, let me do one thing. Let me copy this one. So let me paste it over here. Let me paste it over here. Right. So let me hit the submit button. Let me hit the submit button now. I hope this works, man. I have selected C. I hope this works for all the test cases. Let's see. Have the Java JS TP, nothing but the tutorial point. This is fine. Yeah. Now you can clearly see here, the code that we wrote got accepted, means it works for all the test cases, right? So the code that we wrote works for all the test cases, right? So whatever the code that we have written works absolutely correct. I hope the solution part is completely clear. This is the last problem that we solved, that we'll be solving. I mean, we have already solved this one, right? We solved using the backtracking. So next, let's move on with the topic, this one, try, right? Let's solve some problems on try, basically. So for now, I hope the solution part is completely clear along with the complexities and approach. For now, this is it. Thanks for watching, guys.